So there is a lot of new functionality in the newest release of Whitson Plus. To go through the most important things systematically, I think it makes sense to start with the numerical model, where we've now included multi-layer optionality. So if you open the well and reservoir data tab, you can now add layers by clicking this button up here to the right. And you simply then provide petrophysical properties for each individual layer. And let's say we want to make this a two-layer type of model. And then these parameters right here will be calculated for the total system. But you can also choose which of these are fractured, for instance. So if I say that this layer is the fractured layer and this is an unfractured layer, this is essentially the properties of the layer that's fractured. If I go ahead and save this, what you can also do is not only to assign petrophysical properties to each individual layer, but you can also assign different PVT properties to every individual layer. So that's, in initial water saturation is one number that you can provide here. But you can also assign a different GOR for each individual layer. So here we're going in and saying we have this extended black hole table in the background, and you can now, for instance, put this layer at 1000 GOR and this layer at 500 GOR, and then go ahead and run the model. Okay, so that's how that works in general. The other thing, when it comes to kind of small details here, if you would like to just go back to what it was, you can see that we now have a half-bounded well option. So let's say we are dealing with a half-bounded well. We have some volume beyond the frac tips, but we only would like to include this volume on one side of the hydraulic fracture. We can do that now very simply by just clicking this half-bounded well. And you can see it also kind of illustrated a little bit better probably here in the cartoon above. So there's only a volume beyond the frac tip on one side of the model. Here, before you could actually, there was just a default rock compressibility that was used in the software for the numerical models. That was always for e to the minus 6, but now you can actually go ahead and change that. That's something you change right here. And more probably important for many of you is the opportunity now to set a different matrix permeability set for the matrix and the fracture. So by default in the fracture, we're using just straight line rel perms. But if you would like to, now you can set these to be the same as the matrix rel perm, or you can change this to something else than straight line rel perm. So you have a different set in matrix and fracture. When it comes to the forecasting, there's been a few additional upgrades. The first one is that you're now able to not only use a hyperbolic function when you forecast, but you can also use a linear one. The power there is that you now can set that you would like the pressure decline to be a certain PSI per day or KPI per day or bar per day, and that's being used in the forecasting piece of the data. You can also go ahead and add multiple segments. So let's say I would like to forecast this to 4,000 days here, for instance, and then from 4,000 days, I'd like to go ahead and use something constant. Then I can go ahead and do that. So let's say I like to make it 500 from day 4,000. I just go ahead and input that, and I can add as many segments as I want to account for potential artificial lift installments in the future or whatnot. It just provides you with more flexibility in the forecasting part, which is really powerful. The other thing is that earlier, when it came to the sensitivities, you actually only had the option to do sensitivities on reservoir properties, so physical properties in the reservoir. Now you're actually able to also go ahead and run sensitivities on the well control. What that means is that you can now run the model on a wide range of different bottom hole pressure schedules. So here I'll just define three different cases: a base case, a aggressive case, and a conservative case, meaning that they're just hitting a certain final bottom hole pressure at different points in time. And that can be very interesting for those of you who study, for instance, drawdown management, and when potential drawdown management, at least from a PVT perspective, starts to be important, and you then can plot all these results on the same graph. This is an oil case, so you shouldn't expect there to be a lot of difference between the different cases, and you also see that that's supported by the data here. At least the path dependency is not that important on the final product. So that's most of the important upgrades in the numerical model part. The next thing which there has been a lot of updates is related to the bottom hole pressures. The most important thing now is that we've simplified and consolidated this input card here even more. So now there's only 2 tabs. For those of you who remember how it was in the beginning, it was actually 4. The well deviation survey part is the same, but now the wellbore configuration, you actually set the wellbore configuration and an associated flow path when you input the data, and a artificial lift method all at the same time. So you don't have to actually go ahead and assign which flow path you're supposed to use every given day. That's something that you all do in this view. So that's just to make the life simpler for you all. There's also more options here that you can see, at least on the gas lift part, to have both plunger and ESP as at least new options that you can input here. And if you'd like to account for all the gas lift valves versus depth, you can also go ahead and do that right here. The pour buoy option is just saying that we're injecting gas in the end of the tubing that you've inputted. So that's just a simplified version of this guy right here. Very good. In addition to that, you can also see that some metadata that's really helpful to have, especially when it comes to the calculated values here, can be the tubing and the casing pressures. So now you're able to plot that at the same time in the bottom hole pressure view, which you couldn't before. By default, when you go into the module, so let's say you go into the plot right here, they're turned off by default, but if you like to look at them, you can just simply turn them on by clicking these buttons right here. The same goes for in the smoothing view as well, if you like to have some context for certain data points, etc. Very good. The next thing is related to the analytical RTA updates. There's a few updates here. The first thing that you'll see is that we have now a classical and fractional option. So the classical RTA view is just the view that has always been there. That's the analytical RTA view leveraging the square root of time plot. For this analysis, there hasn't been a lot of updates, but there has been one important new powerful option here that is just what data you're plotting. And the data that you're plotting now, in addition to just the primary phase, you can actually go ahead and use both the total liquid or the total reservoir rates. So that's basically we've converted the surface rates to reservoir rates with PVT and the provided bottom hole pressures, which can be really important in some cases where you either produce a lot of water or where there are significant multi-phase flow effects when you're interpreting this plot. So that's one important thing. The other important thing related to the classical RTA view is this auto fit option. So now you can actually go ahead and click auto fit, and the software will automatically do a best fit of the square root of time plot. So we'll try to find a straight line portion of the data, then pick a associated time to end linear flow line, and you'll see that in this portion of the data right here, the straight line portion is associated with the half slope, and then there's a deviation from that later on. And this autofit option you can actually launch on not only one well at a time, but you can launch it on all the wells in a given project by just going to the wells overview, clicking run selected, and click autofit RTA. There's going to be more, call it batch mode type of analysis like this that's possible to do in the future, where there will be just more options here on what you can do on a wide range of wells at the same time. So this is just the beginning for that, but extremely powerful. The other thing that makes this very powerful now is that we have an API endpoint. So if you like to do this for every single well that you have automatically, with a computer, we can do that for you as well. So just let us know if you're interested in doing that. So then you have essentially all the ingredients you need for a fully automated RTA, at least from an analytical perspective, workflow. We can upload production data and update that automatically every single day. We can calculate bottomless pressures automatically every single day, and we can also now do the autofit of this every single day. So that is everything there is possible to automate, so that you actually don't have to necessarily do that job. A very exciting option, there's been a lot of talk about this lately, is this fractional RTA methodologies. And that's where we have the analytical version, the first version of the fractional RTA here in the software. So you can just do that analysis by clicking fractional here at the top. And what the diagnostic plot here is primarily meant to be is related to providing this an estimate of this delta parameter right here. The plots are very, very similar to the classical RTA. They're actually identical. The only difference is the rate normalized pressure plot here, which is the plot here in the beginning. This plot has is a log plot and not a square root of time plot anymore. But the actual values that we're plotting on the axis here is the same, it's the exact same digitized points. So and the plot is modified in the same way. You're just dragging this slope on the plot, and from the slope we're picking a delta. So now I'm trying to match this portion of the data, and I can also do it on all the different phases. Now I've done this on a total reservoir rate, and my delta is 0.28-ish, where a 0.5 would mean evenly spaced fractures, and a 0 would mean boundary dominated flow. Okay, so that's the difference there, and some value between there is just indicating that you're somewhere in a transitional flow regime. And in the next release, we're also launching the numerical RTA version of this fractional RTA theory. The last thing that's probably important related to this feature is the optionality to add a comment now. So if you'd like to, for instance, here add a comment related to when we go from infinite acting to boundary dominated, I can see that this is time to end of linear flow. I can save it, and then this data point here will show in all the plots here, and also has a timestamp associated with it, and the actual values. So that can be really powerful, and has been requested by several of you. The next thing is related to the numerical RTA. Numerical RTA in this has a few updates to make it more flexible and robust. But the most important ones, at least from a practical perspective, is that you now can lock in these values, the OIP and LFP values. And that's especially nice when you're relaunching a calculation, because every time you relaunch a calculation, the LFP is reset. Or automatically by the software. But you can now say that I would like the LFP to be 70,000, and that means that I can't drag this line up and down anymore. But if it's unchecked, I can actually drag it up and down. The same goes for the OIP number, that when I drag this line up and down, the software is automatically picking an OIP for me. But if I remove or if I lock this value in and I move the line up and down, this automatic new pick of an OIP is not done. And that's very nice if I've, let's say I want to honor the OIP that this has been calculated from the flow material balance, let's say that's 640. This in this case, I can just simply say that, okay, I would like this to be 640. I want to lock that in, and then I'm just changing my LP parameter right here. Or I can also lock in this value. If you've done all the analysis on all the different wells, there's also this input tab right now. So you can see how the flow material balance OIP and OGIPs and the numerical RTA OIPs and OGIPs compare, and also the LFPs from your analytical and numerical RTA. So there's a nice summary for those that are doing a lot of the RTA stuff as well. Many of you have also asked for the opportunity to solve for not only K and XF. So as you've seen in analytical RTA, you have the opportunity to solve for both K and XF, and also XF and number of fractures. And that opportunity was not available in the numerical RTA view until now. So now you also have the opportunity to solve for K and or XF and number of fractures. So then in that case, you're inputting permeability as is shown in this example right here. The last thing, which is really, it's been a large upgrade actually, is related to the production data, and when you modify and edit production data graphically or in software. And before, it was kind of a little bit clunky, especially if you were used to Excel type of tables. But now what you're seeing here is basically the new view, and it's very, very similar to how you would modify things in Excel. And it's all the same commands, actually. They work just as an Excel. There's even some averaging and whatnot here to the right. So now when you're modifying data, either deleting a row or appending a row, you would do it as you would do it in Excel. So if I want to delete this row right here, I would simply just delete it and click save. The same goes here at the bottom. If I would like to add more data, I'll simply just add one row or as many rows as I like at the end of this line right here. The other nice thing is I can also do simple math here. I can plus cells together like you would do in Excel, etc. So that is really flexible and powerful. And for those of you who have done a lot of Excel work before, it should be very, very familiar. So that's a very exciting detail here. And as you'll see, before there was an edit and upload button right here. Now that's just been consolidated into edit, because you can now append, remove, and upload new data all in the same view right here. The last thing that I'll mention is just the new things related to the reservoir fluid composition. So many of you that wanted to find a appropriate initial GOR found yourself going into, for instance, a numerical model or the production data overview to find a GOR that was representative, and then you would go in here and input it. So what we did was, okay, what if we instead provide you with the initial producing GOR or the initial producing OGR in this view, and you can simply just drag and drop this line such that it fits the early production data, which is what we do in reality. So this is the exact same plot as you see in the numerical model. You can, of course, add all production data points in the future, but by default, it's zoomed into the first 100 days. And when I drag this line up and down, you'll see that the initial GOR is set right here. And of course, you can just type it in as well, and it will be set for you. Okay, and everything else is the same, and you can also use the cube option. For those of you who are working in dry gas place, before you could only input the entire dry gas composition. So many of you, if you were dealing with something where you actually didn't have the compositional data, you would just set methane to 100% or something like that. But now there is the simplified input where you can just provide a gas-specific gravity, and if you have the non-hydrocarbons, you can provide that as well. And you click save, and then will work in exactly the same manner. So that's just a new option for those of you who are working on dry gas wells. There's also a few other details that I'll leave out in this video, but you can look at all the details in the email that I sent to you. And if you would like to go through this in a session, just let me or any of my colleagues know, and we can jump on a call to go through this. And especially if you find some inconsistencies or bugs, just let us know, and we'll get that fixed as soon as possible.